This is going to be a demonstration of how to interact with the pay-to-write database, how to read and write to it. The pay-to-write database is a peer-to-peer, censorship-resistant database that retains a lot of the qualities of a blockchain, but is more performant and can hold much more data than a blockchain typically can. So it's a kind of a hybrid between a blockchain and a database. If you think of a blockchain as a really crappy database, this is a slightly better database, but retains a lot of the censorship-resistant qualities. And so the demo today is going to show how to use the command line wallet to interact with it. We're going to take a look at the Block Explorer or the Database Explorer, which is a web UI for browsing data. I'm going to show how to get a PSF token, because that's used in order to write data to the database. You have to provide proof of burn or burn a little bit of a PSF token. And then we're going to explore how to read and write data using both centralized methods and decentralized methods. So let me go ahead and get into it. Before I start this, there is a video that is a prerequisite before you watch this video. It is psf-bch-wallet, how to install and use. You should watch this video because we are going to be using the psf-bch-wallet, which is here in this repository on github.com, Permissionless Software Foundation, psf-bch-wallet. This is the command line JavaScript Bitcoin Cash wallet that can also work with tokens. And in that video, I showed how to basically interact with it. So I'm expecting that the person watching this video has already watched that video and has gone through the steps to send and receive BCH and tokens and connect with the different wallet services. And also, before I jump into the demo, I just wanted to point out that if you want to run your own pay-to-write database locally, just like you'd run a local Bitcoin node or something, this is the repository here, and it has a Docker container. If you read the instructions, you can install your own local pay-to-write database. So let me introduce the Explorer. This is at explorer.fullstack.cache, and it's similar to a Block Explorer for like a full node, or for like a blockchain, where you'd look at transactions. Here, instead of transactions, we have entries in the database. So if you go there, you want to navigate to this Explorer menu item, and there's 4 columns. The created at is when this instance of the pay-to-write database first saw the data. This transaction, if you click on that, will take you to the Simple Ledger Block Explorer. This is the transaction on the Bitcoin Cash blockchain that shows the proof of burn. So the ticket to burning, or the ticket to writing to the database, which anyone can write, is you have to provide a proof of burn of burning 0.01 PSF tokens. So that can be shown here, and that's what the wallet, the Cli wallet, does for us. This second column, or this third column, is the hash, is the actual data stored in the database. So if you click on it, it'll open up this modal up above. It just pushes that table down, and you can drill down into the data for this entry. So it's a valid entry. It passed the rules. That's why it's in the database. This app ID is it can be anything you want it to be, but it's sort of like a category. It's a really handy way to like query the data in the database that all fall under the same app ID. So like if you have a social media app, you can just query the data for that social media app. Or if you have a curated list of websites, you can just query the data for that. So it also provides sharding for the database. There's, what is this? This is the local Mongo ID. This is the Orbit DB ID, or the IPFS hash. This is the transaction on the blockchain that provided proof of burn. And then this is the actual data that was entered into the database. And then the signature from the person who submitted this to prove that they own the address that burned the token. And then this is really the actual data that got put in there. Everything else is basically just metadata. So let's show how to write some data to the database and then watch it come up on this Block Explorer. So I'm on an Ubuntu Linux machine, and I am running Node version 14 and NPM version 7. So if you use a different operating system or different versions of Node or NPM, your mileage may vary. I am going to install everything from scratch, just like anybody else would, and which I covered a lot of this in that first video on how to use this wallet, but I'm just going to go through it real quick again. So I just cloned the repository. I'm going to go over this faster than I went in that video because I'm expecting people to watch that video. But I cloned the repository. I'm installing the dependencies. This will take a minute. With the dependencies installed, you can then look at the commands. And again, I covered this in the previous video. So just to recap on where we are, we just looked at the Database Explorer. And now what we need to do is create a wallet and get some PSF tokens. And so I'm going to show how to do that. You do need to have some Bitcoin Cash. And so let's create a wallet real quick. Wallet create. I'm going to name this test 22. And wallet list. I have one wallet because I just created it. Okay, and so now what we need to do is start the daemon. And this will spin up an IPFS node and connect to the IPFS network, which will allow us to connect to the wallet service as well as the pay-to-write database service. And so I'm in the same folder. I'm going to just let this daemon run in this window, and then I'm going to continue doing instructions in this window. We can see here it found the wallet service, and it's continuing to go out and find more nodes to connect to. So there's some new commands in here that were not covered in the video, particularly with the pay-to-write database. But before I do that, let's make sure we're connected to a wallet service. And so if I do wallet service, oops, I need two L's. Okay, is selected on here, and I'm connected, so it came up. Let's go ahead and get the addresses for the wallet. It's plural. Okay, these are the addresses for the wallet. So I'm going to send it about $1 in Bitcoin Cash. And I just happen to have some in this web wallet that I use for testing. So you will need some Bitcoin Cash in order to follow along. And I have some PSF tokens in my wallet, but I'm not going to use these because I'm going to show how to get them from the Permissionless Software Foundation website. So $1. Okay. So that's sent. So assuming I am still connected to that wallet service, I can get the balances. Okay, so there's the Bitcoin Cash I just sent to the wallet, and I have no tokens. Now, to get some PSF tokens, the easiest way is to go to psfoundation.cash. And the current price is around 62 cents per token. We don't need very much. I'm just going to send it 50 cents. Or maybe I'll just send it 25 cents because we really only need a fraction of a token. And so if you scroll down, there's some stuff here you can read, but basically you send some Bitcoin Cash to this address and it will send you tokens back after 2 confirmations. So bin run. We want to send some Bitcoin Cash. So let's check out the syntax for that. Oh, it's send-bch. Okay, and so the instructions there are the name of the wallet, the address, which I just copied from the website, and then the quantity of Bitcoin Cash we want to send. Okay, here's the quantity of Bitcoin Cash that we have. And so I want to send about 20% of that. So 0.00, what would that be? More than 2,000 Satoshis. I'll go 0.4. That's what I'll send. And so we'll get some fraction of a token back, and we'll see how much we have. But I'm sure it's more than 0.01, which is what we need in order to write data to the database. Okay, so there's the transaction. Let's just check this on the Block Explorer. Now, the way that sort of token vending machine works is that it will wait for one block confirmation before it sends the tokens. So I'm going to wait here, or I'm going to pause it here, and I'll come back after we've had a block confirmation on the Bitcoin Cash blockchain. Okay, so I got one confirmation, and I just did the wallet balances command and saw that I now have some PSF tokens. It sent us about half a token, which is what I was shooting for. So that's perfect, because we only need 0.01 tokens to write data to the database. And so this is plenty of tokens. This is like 50 writes to the database, basically. Okay, so now that we have gotten some PSF tokens, I'm going to show the centralized way of reading and writing to the database. And so if we look at the Block Explorer right now, this screen automatically refreshes every 20 minutes. And so this at 4:49 p.m. was the last entry, and it ends with WBZY. And so there are currently 3 pay-to-write database commands in the command line wallet. And this new one, pay-to-write database service, is pretty important for navigating the decentralized way of interacting with the database, but we can ignore it for now for the centralized database. So let's check out that write command. So we're going to write some data to the database. So we're going to do the -C flag for centralized mode. And centralized mode means that it goes directly and talks directly to this pay-to-write database.fullstack.cache server, and that's what makes it centralized. It's a single service that fullstack.cache offers. And if you go here, it displays this page, which is the API documentation. So there's JSON RPC documentation, and there's REST API documentation. This is really good information if you're a developer and you want to integrate the pay-to-write database into an app, which you should do. I'm hoping that people will do this, but you don't need to know this information just to interact with it on the command line wallet like this. The idea is, if you get comfortable interacting with a command line wallet, then you can look at the source code, you can look at the API documentation, and that's everything you need to start integrating database access, decentralized database access into your app. So, okay, so we did -C for centralized mode, the name of the wallet, and the app ID can be anything. So I'm just going to call it test 84298. That sounds good. And then a string of data, and if you're going to have spaces on a command line, you want to enclose them in double quotes. So this is a test of the during a a demo video. So I'm going to write this string. You can write up to 10 kilobytes of data. So if you had like a stringified JSON, you could copy and paste it in here. And so basically 10 kilobytes of text is what you can write, or 10,000 characters. And so what it's doing now is it's going out to p2WDB.fullstack.cache, and it's interacting with the REST API. That's the centralized mode. And it's burning 0.01 PSF tokens. It's using the decentralized wallet service to do that. And then that's generating the proof of burn. And then it's using the REST API at fullstack.cache, the P2WDB, the centralized one. And it's submitting that transaction ID as proof of burn along with the data. That all was validated, and so it gave us back this IPFS hash, which is the entry in the database that we just added. So if we click on this link, it'll take us to the SLP block explorer, and this shows us the SLP, basically the proof of burn. This shows that we burned 0.01 tokens. This is just a rounding error. And so this is the proof, the transaction ID for the proof of burn. And then if we wanted to access the data directly, not the whole database, but the exact thing that we just added, that's what this link's for. So this is pulling data directly from the pay-to-write database at fullstack.cache. And so this is how you would consume this data in an app. And I have an extension in my browser that this comes back as JSON, and it makes it all pretty like this. So it might not look like this in your browser, and if it doesn't, I recommend you Google like a JSON browser extension or JSON pretty fire. And if we look at the block explorer, yep, there's our entry right here, 525. It's now 526. That's the same transaction on the blockchain we just looked at. If we click on the details, here's the sentence we just wrote. This is a test during the demo video. Oh, and I meant to show that here. This is here's the data that we wrote. So our data is now in this censorship-resistant database, and it's being replicated across the planet into several other instances of the database. And as long as any one of those databases remain in existence and online, they will syndicate the data, just like a blockchain syndicates the data in the blockchain. And, okay, so now we've shown how to write data. How do we read data? So there's that P2WDB-read. Let's check out the syntax for that. We're, again, going to use centralized mode. And we're going to give it the hash, which on a block explorer, here's the hash right here. It's in condensed form, and then you can drill down into any one of those entries if you want to get the hash for that. We have the hash of the data we just wrote, so we can copy and paste that. And so this will read back the data that we just wrote to the database. So here it is. This is a test during a demo video. Okay, so that was the centralized mode. What's the decentralized mode? So centralized here means that we are writing and reading from one centralized location, which is p2wdb.fullstack.cache. That's the one server that we're interacting with. If this server was down, these commands would not work. And that's what makes it centralized. And so the decentralized mode, I showed a little bit of this in the last video on how to use the wallet, in that it naturally uses a decentralized wallet service. So in the previous video, I showed this wallet service command, which shows all the different wallet services that I could connect to. Right now I'm connected to this one, but I could connect to this one, and there will be more here shortly. As members of the PSF community spin them up. So similarly, there is this p2wb-service command, which shows all the pay-to-write databases that I could connect to. And in fact, I am connected to this one, it looks like. That's a little weird because I haven't selected one yet. But that's what I was going to show, is if you do --help, there is a -s flagged for select. So just to explicitly select it, I am going to select this one, which has the Cali extension, so it's in California, and this has EU, so it's in Europe. So anyways, just for good measure, I ran that command, and so it says I'm connected to this one and not this one. So if I have issues, I can just move to a different service provider. Okay, so now that I'm connected to a decentralized provider of pay-to-write database services, I can query them. So let's run that same write command, but without the -c. This is a second piece of data. So now, instead of using the REST API talking to the fullstack.cache server, this is now talking to some random server in California that's offering pay-to-write database services, and it's using the JSON RPC over IPFS. And this decentralized method is really good. Like you can be behind, like, say, the Chinese firewall and still interact with other service providers around the world this way. It's very difficult to censor access like it is with the REST API. It's much easier with the REST API to censor consumption and use. So it went through, same exact user experience, same exact information. Okay, this one popped up. Let's go ahead and, one of the caveats I was going to point out is it might take a few seconds for the entry to show up. What was our hash? T1EAJ. Yeah, there it is. It's right there. So this did pop up on the Explorer. When you use decentralized mode, it can take a few seconds for the entry to pop up because that entry has to be syndicated around the globe, just like a transaction on a blockchain would have to be syndicated across the network. And so it can take a few seconds for whichever pay-to-write database you connect to connect to the fullstack.cache instance. In this case, it only took a second or two. We didn't even notice it. And again, we can use the read command, remove the centralized flag, and put our hash in here. And this is instant because we're reading and writing from the same service provider. So if we wrote data to the service provider, it will have the data. But again, like, the point here is this is decentralized, so there's a couple caveats. It takes time for that data to propagate, but the pro of that con is that it doesn't matter if 1 or 2 or 3 or 4 of these pay-to-write databases go down. As long as any one of them remains in existence, the data will get syndicated, saved, and when new ones enter the network, they will retain that information. And so that's what makes it very hard to censor, and also provides a lot of uptime to users and apps that can consume this data with the pay-to-write database. Okay, so that concludes the demo. I hope that you will play with it. I also hope that while you're at the PSF website, that you scroll to the bottom and click here to join our Telegram group, and click here to view any of our open source code. Everything we do is open source and MIT licensed, so you are free to take it, do with what you want, and make money using it.